beginning, indeed.
Is that a screenshot or is the video?
No, it's the video.
Huh?
Can
Yeah.
you go to the video?
So for context, 2013, some revelations happened that made people stop calling other people tinfoil conspiracy theorists. Do you know this video?
Huh?
Can you put the mouse there?
This is the demonstration about why the people in this room shouldn't be making training materials or training workshops for privacy activists.
Can someone say what's that? Does someone have seen this video before? Another one person. What is it?
Exactly. Edward Snowden, very famous hacker, very elite, had to make this very long video of almost 12 minutes to explain to Glenn Greenwald, how does this encryption thing work? You have like two people and lots of magic and things you don't understand.
And there, because you do things as pretty as going to the pgp.meet.edu, copying and pasting some public key and injecting that into your MUA. So, no, it's okay. So if this is, after 20-something, 30 years of best practices of new PG encryption, what still we have to train journalists that are on a mission-critical thing for sending a very secure email, we have failed.
But yeah, there are easy solutions to that. You just have to look for the magic string. It's all safe now. Right?
We all laugh, but we know that we all do the same thing. At some point, or you have the classical, please don't send me encrypted email, I'm on the go, I don't have my keys in my phone.
Now there are many problems that are there. Like when you do host for your friends or your family or your job, it's kind of like, okay, you have your email there. Email is still relatively easy to move over, but everything else, it's horrible. There are many problems with providers. Do people know this kind of company that had this nice little problem, LavaBit? They were pretty much asked to install a backdoor for one of their customers. It's like, yeah, I have this really nice encrypted email setup, but once people are showing up at your house and pressuring you really hard, then what are you going to do? Shut down the service? Collaborate for this one person you've maybe never heard about and is maybe Snowden? But some people say like, oh, we have this great solution. It's called peer-to-peer. It's going to solve all your problems. That was the hype word. Constant connectivity. Spend hours in front of a regular desktop to maybe get your email. But there's no solution. We just do federation. It's proven. It works, more or less. There is one problem with federation. You want to protect the providers from their user. Because, especially bigger providers, maybe someone has an ex that also has a mail account there, and you're kind of like curious, or all these kind of things, they happen. You have probably friends who, off the record, told things like, yeah, that was kind of fun to sneak in there and like read about something which I'm not supposed to read. So we don't want that. We want providers to be safe. When the provider doesn't have anything, who's going to knock on their door if they cannot give anything anyway? So we encrypt everything for the user. And at the same time, we also want to protect the users from the provider. It's like this going back and forth, this problem. So what do we do?
First, we don't try to solve all the problems at once. Like, this is not, the previous slide is not about how to solve the usability or the adoption or the deployment problem. It's about having a realistic near-term strategy until we have, I don't know, things like email totally fixed, because we know that some flaws in the design are not going to be fixed in the probably next 20 years at the spec level.
Our concept is dual. Like, we both try to make it easier for the people to run email, VPN provider, or related. I mean, you can call it differently, like it doesn't have to be VPN. You can also try to run other services on it. And the second aspect is what Kali was saying. You can't solve everything at once. So there are some things like, okay, what kind of little baby steps can we take? We can say, okay, you don't have to trust your connection provider. Who trusts? Here's the nice little open FOSDEM network with tens of thousands of hackers on it. I don't know. So there you have your VPN provider. And then we have the bitmask client to actually make it easy for the end user to run it. And it's supposedly, well, it basically, the presumption is that the provider is running this specific platform, and the bitmask client can use then any provider who sets that up.
So the basic assumption here again is that there are no silver bullets, and the diagnosis of the problem is that it is fundamentally an usability problem, both at the level of provisioning services and at the level of getting users install something that it doesn't require to do a PhD on cryptology to understand.
I don't think we stress that enough, but sysadmins are humans too, and they also deserve usability. And many of the tools that we develop for sysadmins are horrible and really hard to use. And one of the aims of LEAP is to try to make that easier.
Without breaking interoperability. Basically, again, the premise is that it doesn't matter if we come up with the perfect crypto, peer-to-peer, super secure, super paranoid solution, if that breaks compatibility with existing solutions.
Lovely. Maybe it helps to not have it full screen? No. Sorry.
Control minus.
What? Control minus, that's an idea. Hey. So LEAP, the email service is one aspect of what we've been doing. A very important aspect of it is like end-to-end encryption. You want to be sure that it goes from the end user to the other end user if both are using bitmask. But yeah, it's backwards compatible. So if the other person is not using it, but is using OpenPGP, that's fine as well. If the other person is not using OpenPGP, it falls back right now just to use regular email. So it's kind of nice that you have this huge user base which you can hook into and slowly step up. A very important aspect is everything is client encrypted. So that means you have a little daemon running at your desktop or at your mobile phone or wherever that encrypts it locally. The other major point is the automatic key discovery. We all know this is horrible. You just which key do you grab for this person? I maybe sign it, did they lose it? Oh, they didn't renew their expired keys. So we want to make this automatic. One of the kind of things that you really trust is your email provider or your VPN provider. So these people should be okay with you saying my provider knows which key I use, so they can sign it, and then there is this interoperation. There are many little aspects there, and very important these days, you have how many devices? 3, 2, 7, and you want to read your messages on each device. So we have the magic word there, cloud synchronized for high availability.
Web scale.
This is basically the architecture. I can use a microphone. Yeah.
This is basically the architecture of the email service. We have here the separation between what's the server and what's the client. So that's the LEAP platform and that's bitmask. There is some interesting point. We have slides step by step, isn't it? Maybe I can go step by step. So from one side, bitmask is not really an email client. It does open a local service of a local IMAP and SMTP port, so you can plug whatever email client you want to it. We have a plugin for Thunderbird to make the life easier and to configure the cache. So So we want to configure Thunderbird in a way that is not storing emails unencrypted in your hard disk, because bitmask deals with storing your email encrypted. Can we go back? Okay. Yeah. Yeah, exactly. I'm almost there. Yeah. We also have an integrated email client inside bitmask, but is very it's mostly a proof of concept, so you can open your email with one click, but it's better to use a MUA. Yes, let's go forward. That's probably one of the most interesting pieces that we've been developing. You want to go? Yeah, okay. This is Soledad. He was talking about the web scale thing. So we develop our own synchronization mechanism for documents. We use it for email, but it can be used for many other things. So instead of talking with the provider by normal IMAP protocol, our providers serve this Soledad system where everything is encrypted locally in your computer in a SQL Cipher database, and is synchronized to the provider, so the provider only see encrypted blobs, and you can synchronize between different clients, and they deal with all the problems of collisions and stuff like that.
Mesca didn't really learn the acronym ever. It basically means synchronization of locally encrypted data among devices. So what we did is just get one genius idea that Ubuntu had back in 2012. It was called U1DB. It was some abstraction, very slight abstraction layer on top of, basically we're using Couch at the moment, but then they had some problems and migrated to Postgres. So we got that and added encryption in there. And this year, with a grant from Mozilla, thank you guys, we finalized splitting the chunk, the bulk of the data from the JSON store. So we right now are not abusing the JSON store for putting there your attachments, for instance, but you just do that for synchronizing the headers and the MIME tree parts, and the other part is just write whatever backend you want for storing dummy encrypted blobs. We are quite happy about that, and we are hoping that there will be some real performance in there, because that also means not having to do massive atomic syncs. So right now we can have like a different store per application and these kind of things.
One of the magic things of Soledad is that it's generic document storage, so we use it for email. But for example, we also use it for keys. So all your key ring or your OpenPGP key ring is stored there and is synchronized between all your devices. And we haven't done anything more with it, but it will be trivial to do things like password managers or whatever on top of it. It's not really great for big files. He said that we're improving that. It might be at some point a good place for restoring files, but yeah. The missing piece in the original diagram is the MX service. So your provider to the outside world is communicating using SMTP as every email client, so as every email server, and so emails arrive to it. Whatever they arrive encrypted with OpenPGP or they arrive unencrypted, we have this service that every email that arrives is encrypted, the full email, including headers and everything. So in the hard disk of the provider, there is never unencrypted emails. They are encrypted to your public key. So when we fetch the emails with Soledad, it will be unwrapped and stored properly and stuff like that. So your provider only holds your emails in memory when they arrive, if they arrive unencrypted. Can we? Yeah. So that's the full picture.
Just one thing, because I know that this is not the prettiest diagram and people get confused here. So this means that basically if you write encrypted email to your provider, everything is fine, you will get it decrypted in the client, and once it is decrypted, you just store the parts of the MIME messages, so your other devices can be bootstrapped and have the same view of the inbox and of your key material. And if you receive a plain text email in the provider, it will be opportunistically encrypted and deleted in clear text from the provider. So from that point on, it will be stored always encrypted.
Keys, we've mentioned them a lot. Let's start with what kind of keys do we get? What kind of keys do we trust? I think we have to, again, go with the small steps first. If there is a key attached to that email provider or that email name, then it's maybe likely that they will be correct, maybe not. There's, we have the key discovery, which I said before, we also have an endorser. It's like pretty much spec'd out, but maybe start with the beginning, tofu. It's like nice, but not always. So in the first contact, when you discover several keys, which one are you going to trust? We set up a bunch of like heuristics which are elementary and understandable, I think. So if you discover one key, then okay, that's fine. If you have several keys, which one are you going to trust? Are you going to trust the one that's signed by the other person's provider, maybe? That's a nice start. And we have these different levels of like adding more and more possibilities to make sure that this really is the key we want to use.
One of the main things on how we design the key discovery is to try to don't make our own solution to this key discovery and try to be compatible with what is outside. So we have this proposal of signing keys by the provider, but we also support using key servers. We also support the web key directory of NuPG or whatever proposal comes out that looks interesting. We kind of designed the key selection in a way that we want to support whatever is outside the community.
Autocrypt, for instance.
Autocrypt.
That's what the cool kids will be doing this year. So yeah, the idea is just you don't break with all the key management practices, but you have bots, or you have his software, key manager, doing that on behalf of the user. Without I think the basic complexity here is empowering the user to do things little by little. So you don't have to learn everything about the best practices for signing and refreshing keys and all these things that really broke the PGP Web of Trust ecosystem. You start to have a bot doing that, like refreshing your key, rotating them, having subkeys, etc. But don't hide that completely from the user. Just have some accountability to explain to the user. That's the core idea behind this. Explain to the user why did you pick this key, because it was the best that you bought, that you could get on the chain of betterness.
One of the things which is very important these days, people have learned, like, I should put an expiry key there, because I don't know how many people have used OpenPGP in the past, but maybe you did it like 10 years ago or 20 years ago. Do you still have access to that very old key? So having expiry keys is great. You never know when you will lose your device. But that also means that you need to refresh those keys from your friends. Which ones are you going to trust? The ones that are just new, popping up? Or are you trusting the ones that have been signed with the old key? And there's like all these different kind of things we've been trying to set up and come up. So we also have like key replacement, like using this nice lingo from RFCs, like key must be replaced by a new key in one of these situations, and only in one of these situations, like if it's verified, a verifiable key transaction. If the user manually says like, really, I trust this key. If the registered key, like the old one, is revoked, or if it was expired and the new key is equal or higher validation level. All these things, as said by Callie, we don't want to expose the user to it. But we've thought about it, and it's there. It's in the back end. And if
basically, this is the list of exceptions to tofu. So we basically trust keys, always the existing one, except if one of these cases happen. The first one, the verified key transition, sounds really weird, but basically means that if your new key is signed by the previous one. That is nowadays a very common mechanism that many people do, because everybody's trying to drop the 1024-bit keys and rotate it to something else. Yeah.
Exactly. Then there is another part. Seemed pretty popular service, the VPNs. What do we want to prevent? Basically, the open networks, the typical examples of cafes. But one of the nice things, I think, it's currently not built in, but it should be there, like to hook in different transport mechanisms, whether you like garlics or onions, it's up to you. So that prevents that basic elemental kind of eavesdropping. If you use, if you use Tor, then you could even like step it up a little bit more. We also do our very best to prevent leaks, like the typical IPv6 leaks, or you would sign up for cheap whatever provider you've heard about once on the internet, but maybe they're leaking their DNS. Things like that. We do spend a lot of effort in trying to make that work. It's not always easy because the world changes and then Ubuntu comes up with a new system of how should we deal with DNS.
Here there is a common joke. Did you finish?
Go ahead.
I'm usually very criticized because of making this joke, so I want to amend it. I say that VPN is a backdoor. I want to explain this. The rationale in here is that users nowadays are so trained to have a webmail for free with 15 gigabyte storage that it is very their expectations are too high, so they are not going to install one traditional MUA, a mail user client, just for having secure email. But on the contrary, we thought that the acceptance of the end user to install some new software to use a VPN is much higher. Like the risk the threat model and the incentives are aligned differently. So the core idea behind bitmask is to offer these two things with the same client. You install it because you use a VPN, and for free in the same package you get a whole re-encryption local mail proxy. That's the concept idea here.
The backdoor to get you all hooked. No, it's not like a backdoor like we want your machines. No. LEAP platform. We have little time left, but that's okay because, as we said, like sysadmins want to have weekends and stuff like that as well. So to set up a new provider, you're done. This is basically installing a little gem to have the command line tools at your trusted machine. We don't want it.
Here it says LEAP deploy.
Yeah, exactly. Like you do a couple of things, like you have a domain name, you have some DNS, and then you say like, okay, use these machines, initialize, and deploy, and go. And that's basically all there is to it. On the background, it has a bunch of Puppet recipes, not always self-explanatory, but we try to have a firewall, we have to have all those different services like VPN or email, or you can say like, oh, I only want to have VPN. Then you say like, this node is for VPN and not for other things. So there are possibilities, there's a range of possibilities because we all like to customize our things.
With encrypted storage in mind, right now the module that is using it is encrypted email, but it should be fairly trivial to use that for offering other things that we are not working currently in, but it should be very easy to do key managers or encrypted paths or things like that.
So yes, LEAP deploy, that's the magic, that's where it all happens. Also we have Let's Encrypt built in, so you can actually fetch and renew your certificates, which is really nice. There is one little issue which I have had personally in the past, like, yeah, I want to give my whatever relative a little email account, and on this, like, I didn't have webmail or stuff. So I didn't have a way to provision users without using the SQL. But now we have this nice little user control panel for adding new users. If you have a little club or hackerspace or whatever to run it there, that works fine there.
For registration, basically considers open registration or invite codes.
Yeah. It's both your user panel for people to sign up with your service if it's not anonymously available for anyone. And the other possibility is to like get rid of old users that are not, I don't know, maybe you do a donation-based thing or you have something else. There are some basic stuff there like ticketing and payment gateways, but that's all boring stuff. So I missed something. There we go. Show me the code. It's at hexacap.org, LEAP. We have about 10 important repositories, lots more that are like incorporated from other places, and it's all GPL.
If you feel like hacking on the code just right after exiting the room, mainly the client code is Python with a heavy use of twisted. We are always looking for nice twisted hackers. And there is some Ruby on the platform, on the web app, and a lot of Puppet on the magic thing that the sysadmins do.
Yeah, or Magic One. We do also really appreciate usability. Okay, I'll keep the current state out of it. So let the 1,000 providers bloom. And I was told we have no questions. I don't know. Fast questions.